Good morning, everyone. I'd like to welcome all the participants to today's session on our biodegradable materials standard, and we're pleased to have everyone with us today. We will give maybe 2 minutes for additional persons to join us, and then we'll start the meeting officially. Good morning, everyone. So I would like to welcome all the participants to our stakeholder forum on the draft national standard for biodegradable products. My name is Nadita Ramachala. I'm the manager of the standardization division at the Trinidad and Tobago Bureau of Standards. And I'd like to thank all the participants as well as our presenters today for participating in this session. And just in terms of the ground rules, today's session is being recorded, so you need to give your consent to continue. Also, we will take questions via the chat facility, so we will be monitoring the chat. We also have a question and answer session, and you can raise your hand and unmute at that point. So I would like to start today's session by giving a brief welcome again. So we welcome all the participants. This is a second session that we are having on our biodegradable product standard. And at today's session, it is a follow-up from 2019, when we would have had Dr. Kelvin Okamoto with us to go through some of the key requirements from the well-known ASTM standards for biodegradable products. So without further ado, I would like to introduce you to Mr. Rodney Ramnath, our Acting Executive Director at TTBS, to deliver the opening remarks. So Rodney, I turn the session over to you.
Good morning, Nadita. Are you hearing me? I'm just doing a quick mic check.
We are hearing you loud and clear.
Great, thank you. Good morning, everyone. It is my pleasure to welcome you to this stakeholder webinar on the Draft National Compulsory Standard for Biodegradable Materials, which are used for products and packaging in the food industry. The main objective of this webinar is to provide a forum where we can engage all manufacturers, importers, and distributors, both wholesalers and retailers of biodegradable products and packaging, as well as other interested stakeholders on the key technical requirements of the draft standard, the main stakeholder comments received on the draft standard so far, and the proposed disposition of the comments to ensure a common understanding of the technical issues related to the requirements for product or packaging characteristics and labeling. And this session is critical towards ensuring that the final version of the standard is practical and implementable. According to the European Bioplastics, market research has shown that production of biodegradable products is expected to increase by 15% over 2019 production figures by 2040. More recently, another market research company, Grandview Research of the United States of America, stated in their trend analysis report of June 2021 that the global bioplastics market size was valued at US dollars 9.17 billion in 2020 and US dollars 10.2 billion in 2021. It is expected that the market will register a compound annual growth rate of 17.1% from 2021 to 2028, with a revenue forecast of US dollars 30.9 billion in 2028. Other research organizations have predicted a compound annual growth rate of 11.5% from 2021 to 2030, with a starting value of US dollars 5.8 billion in 2021 to US dollars 16.8 billion by 2030. By the way, it is important to note that packaging alone accounts for more than 50% of the bioplastics in a very dynamic global market. Further, it is estimated by EU think tanks and researchers that replacing 1 to 5% of non-biodegradables with bio-based products will create a significant impact in improving both terrestrial and aquatic ecosystems, thereby improving planet and human health. While there may be disputable variations in these presented figures, one trend is clear. The market demand, size, and value for biodegradable products will increase worldwide, and this will certainly also be the reality for Trinidad and Tobago. This increase in biodegradable products on the market has been driven by factors both internal and external to Trinidad and Tobago. These are the constant references to sustainable growth, carbon neutral technologies, recycling and recovery of environmentally focused and circular economy concept messaging, and in some cases petitions of NGOs, corporate citizens, and concerned persons. Preferential consumer behavior towards products which are considered to be of minimal impact to the environment, the adoption of biodegradable packaging for prominent consumer products, and the evolution of the food industry in the design, development, and promotion of the use of packaging alternatives to plastics. These key drivers for sustainable packaging bring to the fore the importance of clear consumer understanding of biodegradable products and the need for market transparency on the part of the manufacturers, distributors, and retailers as it relates to product identification, substantiation of claims, and product quality. The primary mandate of TTBS is to develop, enforce, and promote standards for the protection of public health, welfare, and safety, and the protection of the environment. And towards this end, it is critical that adequate information be provided to the consumer or user for the prevention of misrepresentation or even fraud arising from possible misleading labeling. In this regard, TTBS is fully committed to the development of national standards in support of the government of the Republic of Trinidad and Tobago's trust to control expanded polystyrene from the market and ensure alignment of national requirements to international benchmarks for enhanced competitiveness and improved trade potential for biodegradable products. Today's webinar will highlight the requirements of the national standard TTCS 920, hopefully 2022, biodegradable materials, food contact, single-use products, and packaging compulsory requirements. The standardization process and the national perspective on biodegradable materials. This draft standard is a new proposed compulsory standard that outlines the characteristics and labeling requirements for single-use food contact products and packaging, including food service containers, cups, utensils, and prepackaged containers. The draft standard is intended not only to support the legislation proposed by the government of the Republic of Trinidad and Tobago via the Ministry of Planning and Development to control certain types of expanded polystyrene products, but also to ensure that the products labeled on the market as biodegradable comply with minimum requirements for such products to promote environmental and consumer protection. Standards provide a basis for improvement in any industry, for any service or product, and in any process. They are the tools to promote trade and reduce technical barriers to trade. I would like to thank Dr. Kelvin Okamoto, a technical expert and chair of the ASTM D2096 subcommittee that deals with biodegradation and bio-based standards for plastics, and is vice chair of products for D20 Plastics, for his overview of the key standards and test methods at today's session. Our proposed draft standard utilizes a number of standards from ASTM International, and TTBS has a long-standing memorandum of understanding with ASTM International. As such, Dr. Okamoto is providing TTBS with technical guidance to assist in the finalization of the national standard. In addition, we also have two experts, Ms. Madha Flores Campos and Ms. Gabriela Soler, to highlight a new regional project in which TTBS has been participating. Ms. Flores Campos will provide an overview of the Caburec project. This project is entitled Quality Infrastructure for Circular Economy in Latin America and the Caribbean, and is being delivered by capacity building and technical and scientific organizations using regional experiences and knowledge. Caburec is an instrument developed and implemented by PTB, which is the German Metrology Institute, and the General Secretariat of Organization of American States, in cooperation with COPANT, which is a regional standardization body in Latin America, and the Inter-American Accreditation Corporation, IAAC, as well as SIM, which is the Inter-American Metrology Organization, aimed at providing support to countries in Latin America and the Caribbean. COPANT, IAAC, and SIM are the project partners, while OAS is the project counterpart. Ms. Soler will also highlight the circular economy for plastics and the importance of quality infrastructure. We believe that a collaborative approach is critical to the development of the local biodegradable packaging industry, and it must be based on the use of national, regional, and international standards. The use of agreed standards can assist in increasing market access and boost consumer and investor confidence. Therefore, the TTBS continues to work closely with the private sector, with organizations such as the Trinidad and Tobago Manufacturers Association, the Trinidad and Tobago Chamber of Industry and Commerce, and relevant government ministries and agencies to promote the growth and development of the biodegradable materials subsector with the adoption and use of standards. I commend those stakeholders who have contributed to the standardization process by sharing their views and positions on the requirements of this standard. It must be noted that whilst the development of innovative and safe biodegradable packaging solutions is imperative to addressing pollution and achieving a more sustainable future, building a more effective waste management system is also a key factor that has to be tackled in a collaborative manner in order to maximize the benefits of sustainable packaging. Additionally, we recognize the importance of the circular economy and the need for optimization of the life cycle of packaging. With the circular economy, we need to innovate to ensure that plastics that we do need are reusable, recyclable, or compostable by re-examining and rethinking product use and design. The discussion on plastics in a circular economy is complex and requires meaningful collaboration to develop new solutions, change consumer behavior, and build the requisite infrastructure for the development, production, and disposal of plastics. Biodegradable and compostable materials is just one small part of this global conversation. TTBS will continue to play a role via its participation in ISO's Technical Committee, TC323, for Circular Economy, and would like to encourage your participation in this committee to maximize our national contribution to the UN Sustainable Development Goals. In conclusion, I wish you all a very productive session. Please feel free to make your comments and recommendations towards the finalization of the draft national standard for biodegradable materials. I take this opportunity to thank you for participating in today's webinar, and I encourage you to continue to support TTBS in building a standards-conscious society where standards are adopted and implemented for the improvement of the quality of goods and services sold and used within our Twin Island state. I thank you all very much for your attention, and I will now hand back over to Nadita.
Thank you, Rodney, for the welcome remarks and giving an intro into TTBS's mandate in this regard. I would now turn the session over to Ms. Adrienne Stewart. Adrienne is a standards officer at TTBS with experience in national, regional, and international standardization. She is the technical secretary for the advisory and national mirror committees on biodegradable products and represents TTBS on the ISO Technical Committee 323 for the circular economy. And she's also currently the TTBS project lead for the CABREC project that Rodney mentioned that is focused on the quality infrastructure in the circular economy. I would just like to acknowledge the members of our National Mirror Committee for Biodegradable Products, which is chaired by Dr. Beckles, and also the Internal Advisory Committee comprising standardization and members of our Conformity Assessment Division. Adrian will provide a status update. We have gone through the public comment period for this particular proposed compulsory standard already, and we are at the point where disposing of comments with the technical support being provided by Dr. Okamoto. So Adrian, I turn the session over to you. Adrian, please turn on your mic.
Okay, I'm so sorry about that. Good morning, everyone, again. The intent of my presentation this morning is to provide information on the requirements of the standard TTCS 20XX, and we hope that that 20XX will change to 2022. But also, I would like to bring some clarity to the subject of biodegradable products, because we have a mixed audience here this morning, and we just want to be able to foster greater awareness of biodegradable products and ensure that we are all on the same page when it comes on to biodegradable products. So this morning, I'm going to start with the TTBS's mandate, just to bring some context to the subject matter and to the standard itself. And then we're going to look at the background to the standard. Next, we will look at the key requirements of the standard. And finally, we go to the next steps in finalizing the standard. So the TTBS's mandate is to, as it relates to standards, specifically, is to develop, maintain, and promote standards. And this is to ensure that there's acceptable quality in goods and services produced or used in Trinidad and Tobago, to improve efficiency and competitiveness of the industrial sector, to safeguard public welfare, and to protect the environment. And this is based on the Standards Act 18 of 1997. Let me just to ensure that we all understand how we develop standards at the TTBS. I'm going to go through step by step what the process is for doing so. First of all, what we have to identify that there is actually a need for the standard, and that the standard is solving a problem, whether it's a quality problem, a labeling problem, a product specification problem. Standards address problems. We do so by going through what the ISO methodology for the development of our national standardization strategy. And this strategy prioritizes standards using various factors: export, import data, impact on the environment, consumer needs, and so on. And the standards are prioritized and placed on our national standardization program. Having been placed on the program, the standard is assigned to an officer, and this officer will do desk research, looking at technical and marketing information to support the work on the standard, after which a working draft is developed. Following the working draft's approval, there is the convening of a specification committee of usually national experts or national key stakeholders from a range of sectors: academia, private sector, public sector, non-governmental organizations, ministries, related businesses to the particular standard which is being developed. The committee finalizes what is called a committee draft, and that goes to public public consultation, which is usually for a period of 2 months. We welcome comments on the draft standard. And these comments are taken into consideration. The committee reconvenes, finds resolutions for these comments, and then the standard is finalized and it goes to the TTBS's board. There's a 2-tier system for approval. The first, which is the Technical and Marketing Committee of the TTBS, and next it goes to the Board of Directors of the TTBS prior to the standard being published. There are a number of steps in between approval by the board and publication. And one of those steps involves the declaration of the standard as a national legal document. So what is the specific background into this particular standard that we're going to be speaking about this morning? In 2018, the Ministry of Planning and Development made a request to the TTBS to develop a standard for alternative products to expanded polystyrene products. Somebody's mic is on. Can you just mute for me, please? Thank you. In 2019, the request for TTBS to be a part of the process was put to the cabinet, and a cabinet decision was made to, number one, limit specific finished goods of expanded polystyrene products into Trinidad and Tobago as one. The other decision was to remove customs duty for at least a period of 2 years initially. And the third one was to allow for safe additives to be used in expanded polystyrene. So to explore the possibility of the use of those safe additives. In late 2019, having received the request out of cabinet, the TTBS convened the advisory committee to start the work on the standard. Further, in 2020, the National Mirror Committee was convened. The advisory committee chaired by Ms. Nadia Prasad of the Implementation Division of the TTBS, and the National Mirror Committee chaired by Dr. Denise Beckles of the University of the West Indies. And I want to thank these two committee members and chairs for their continued commitment to the process. In 2021, the standard would have gone to, well, late 2020 into early 2021, the standard was at the public comment stage, and we received several comments from our national and some international and some regional stakeholders as well. The standard was also notified to the World Trade Organization. We did not, however, receive any comments from member countries of the WTO. In 2020, the TTBS would have become a part of the Cabaret project, and the standard became one of those deliverables under this particular project. And we're hoping that in 2022, we can have finalization of the standard so that it can be published as a national standard. As we can see along the timeline, we have had several stakeholder forums. At the end of 2019, we would have had a stakeholder forum with Dr. Okamoto. At the end of 2020, we would have had another stakeholder forum outlining the various requirements of the standard, as well as several presentations on biodegradable and compostable materials. And here we are again in 2022, ensuring that our stakeholders are included in the process. What is the intent of the standard? First, it's to support government policy on alternative products to expanded polystyrene. It's also to provide a means for verification of product claims on those products which are alternative products. And it's also to establish a common understanding by all stakeholders of not only the requirements of the standard, but also understanding on the products themselves. So I'm going to look at the scope of the standard. The standard applies to imported and locally manufactured biodegradable, food contact, single-use products and packaging. It outlines the compulsory requirements for the aforementioned products and packaging, as well as the mechanisms to demonstrate compliance to these requirements, and also includes measures to be taken in the event of non-compliance. The standard does not apply to secondary packaging, that is the outer wrappers or cartons or non-food contact products. It also does not apply to packaging material used as stuffing to prevent damage to products. Now, other packaging materials or other products that contain that are used in industry, these may be under the ambit of the TTS 76.1 general principles for prepackaged goods, or TTS 76.2 specific requirements for prepackaged goods. What are the normative references that we would have used? What are the standards that we would have consulted in the development of our national standard? There are 4 different sets of standards that have been included. First would have been standards that outline biodegradability and the minimum requirements. So those, and we would have looked at ASTM 6400, ASTM 6868, the EN, which is the European standard, 13432, and 14995. And there's a possibility of also including the ISO 17088 standard. The test methods for this integration would be the ISO 16929, ISO 20200, test methods for biodegradation, ISO 14855, both parts 1 and 2, ASTM 5338, ISO 14851, and the ISO 14852. To test for metals and ecotoxicity, we looked at CR 13695 and the OECD guideline for 208. Now, all of these standards are standards which are also referenced in those standards with the minimum requirements. So the international standards, by extension, also references the test methods, the standards, the test methods that we have here. The standards has an entire clause for definitions, but I'm not going to go into this too much. Dr. Okamoto will explain a little bit more on this, but needless to say, the standard has definitions for products that are considered to be biodegradable, products which are considered to be compostable, bio-based, and oxo-degradable. The labeling requirements. Of course, the label needs to be in English. There needs to be a brand name. The manufacturer, distributor, or retailer needs to be identified. And of course, we have to have the country of origin for trading and export purposes or import purposes. Description of the goods. What is the content? How many pieces are inside the primary pack, the secondary packaging? And what other information in terms of content needs to be on the package? The main constituents of the product. What is the product made of? That needs to be on the packaging so that consumers may know. Consumer recommendation, whilst this basically has nothing to do with whether the product is biodegradable or not, of course, it provides for safe use of the product. And some products will require storage information to be included. Not all products will require such information. Now, if the product is a single item product, of course, it cannot be able to have all of that information on a single item product. So single items would have brand name and the applicable recovery method that is necessary for the product to be considered biodegradable. All right. One key area is the labeling misrepresentation? Is the labeling misleading? So the standard ensures that consumers understand what it is that they're purchasing. And so the words green, safe, environmentally friendly, eco-friendly, or any other such designation shall not be used on the labeling of the product or the packaging. And the reason for that is that these terms really do not give the consumer any additional information on the product. In order to be considered to have adequate information, the specific time frame for biodegradation needs to be included and known. The conditions under which that biodegradation is taking place and the level of biodegradation needs to be known. And the words green, safe do not convey that information. The criteria for biodegradability, disintegration and biodegradability takes place almost simultaneously. Starts with disintegration, which is a physical process, breaking down the material into smaller particles. And as such, less than 10% of the product, when it's disintegrated, should pass through a 2 millimeter sieve. And this should take place within 84 days. Biodegradability, more than 90% of the organic carbon in the product should be converted to carbon dioxide. Additionally, this is fine, but also it is important that during the composting process, that there is the absence of negative effects on the composting, or that it does not negatively affect the composting process. And at the same time, it is important that there is eco-viability of plants in the resulting compost. So heavy metals, limits on heavy metals and fluorine are important. Minimum requirements, all the limits of the reference standards need to be met. The requirement for heavy metals also needs to be met. And it is a sum of concentration of all the heavy metals, lead, cadmium, mercury, and chromium, which are the ones that are stated in the standard. And these must be present, not exceeding 100 milligrams per kilogram. Fluorine should not exceed 100 milligrams per kilogram. And oxo-degradable products are not considered to be biodegradable products for the purpose of this standard. Next steps in the process, we believe that the finalization of the standard would allow for common market requirements. It will allow for consumer clarity and confidence. It will allow for consumer value, that what the consumer is paying for is what the consumer will be getting. And it will allow for further investment and financing in this sector when everyone is of the same common understanding and the market is growing. Our next step will be to finalize our response to our stakeholder comments that we have received. We have already resolved quite a bit of the comments, and I really want to thank those manufacturers and importers and distributors in particular, as well as the general public who has sent us comments on the standard. We appreciated it. And I'm also glad to know that some of those persons that would have commented on the standard is at today's meeting. When the committee finalizes the draft, the response to those comments will be made available, will be made available to, at least in the first instance, to those persons who would have commented on the standard. Standard will go for final approval, and after final approval, it will be published, and all stakeholders will be notified that the standard has been published. Usually, then there would be a further stakeholder meeting to look at the implementation of the standard. So it is standard is never trusted on the stakeholder. There is normally a process between when the standard is notified to the stakeholder and when the standard comes into effect. Thank you so much. That is the end of my presentation. If you need any further information, you can email me at adrian.stewart@ttbs.org.tt or call at 662-TTBS. Thank you so much for your attention.
Thank you, Adrian. So in the interest of time, we'll go straight into the next two presentations, and I'm pleased to welcome Engineer Madha Flores Campos, who's a certified consultant with over 20 years of experience in quality infrastructure, quality management systems, competency management systems, general metrology, and organizational development. I will not read the entire bios for all our experts today, but we will put a link in the chat where you can access the full bios. So without further ado, Madha, the session is yours.
Thank you very much, Nadita. And first of all, I want to thank TTBS for the invitation, and I congratulate you for working in these important topics of relevance in the whole world. Okay, I'm going to briefly talk about the project in which TTBS is participating, representing all the pillars of the quality infrastructure. I mean, metrology, standardization, and accreditation to support the circular economy in plastics in Trinidad and Tobago. Okay, as you can see from this slide, our project counterpart is the Organization of American States, and the implementation partners are COPAND, Pan American Commission for Technical Standards, EAAC, Inter-American Accreditation Cooperation, and SIM, Inter-American Metrology System. And of course, PTB, who is financed by the BMZ, the Ministry of Economy for Development from Germany. Okay, and the project has been planned from 2020 to 2023. Previously, a mission for identification, the 3 value circles in which we are going to work was addressed, plastics, construction, and agri-food. And the objective, as Mr. Rodney Rahman has mentioned, is strengthening the quality infrastructure for circular economy in Latin America and Caribbean, and enable and enhance the collaboration between quality infrastructure and circular economy. Okay, we are convinced that working on this topic, circular economy, is important because the high contribution of circular economy to the Sustainable Development Goals. As you know, several Latin American governments formalize policies for the circular economy, and international organizations support the transition towards circular economy in Latin America and the Caribbean. Also, ministries of the environment promote the regional alliance for the circular economy in all the region. We have a lot of initiatives. And finally, circular economy gives an orientation for building back better after the COVID-19 pandemic. But PTB is concerned about the role of quality infrastructure in the circular economy due to the relevance in the world, but what about the quality infrastructure? For that reason, PTB selected the CABUREC program for support this project and promote the interlinkage between circular economy and quality infrastructure. Okay, so CABUREC. What is CABUREC? CABUREC means capacity building in technical and scientific organizations using regional experience and knowledge. This means that this strategy is applied in 2 levels. As you can see from the slide, we work in a national level because each country works in the implementation of pilot projects and the importance articulation of the national quality infrastructure with the circular economy ecosystems. How many countries do we have? We have more than 20 countries that are working in these 3 areas: plastics, construction, and agri-food. And as you can see in the slide, Trinidad and Tobago is participating in the working group of plastics, circular economy for plastics. And I'm very happy that you are with us in this working group. And talking about the regional level, is due the we work in the systematization of experience and lessons learned for the regional quality infrastructure and regional and international circular economy organizations. We have a lot of workshops in which we share our experience, and it's a very, very, very good experience. Okay, then in Kaburek we are participating in this working group, and the working groups are created with representatives of the 3 pillars of the quality infrastructure, with the technical direction of a technical committee led by PTV, and with the support of excellent coaches from quality infrastructure and circular economy, as my colleague Gabriela Soler, who will explain why the circular economy of plastics requires the quality infrastructure. So, Gabriela, the floor is yours. Please go ahead, Gabi.
Thank Mara. Okay, I will share my presentation. Okay. I share with you, sorry. Okay. Okay. Thank you very much, Trinidad and Tobago Bureau of Standards. Thank you. I will continue with the presentation of MADA, the Kaburek program, to tell you about the perspective with which we are working from the plastic work groups with the national projects. The plastic crisis is one of the great challenges facing planet Earth. Finding viable solutions to plastic pollution is an urgent goal on a global scale. Let's see some data. Today, almost 30% of the world plastic production goes to the plastic packaging, like as you see in this picture. These are the packaging are products that have been designed and produced to be discarded after being used. Of all plastic that is produced today, only the 2% is recovered and recycled for products the same use and with the same function that have been designed and placed on the market. The 80% of plastic today is lost, some as waste in landfills, and about 30% leaks into the environment due to poor waste management, open dams, or lack of waste management. The science reports on the environment situation are alarming. The Caribbean Sea is the second most plastic contaminated sea in the world after the Mediterranean Sea. The micro and macro plastic found in it come on a large scale from the North Atlantic Ocean. So, what does the circular economy propose? What tools does it offer us to face the plastic crisis? The circular economy, is an economic model based on a systemic view which proposes to think of closed loops of material resources, energy, and information for what? To generate efficient cycles of resources, work, reducing waste, and therefore pollution, among other issues. The circular economy is a regenerative model based on the principles of nature, with the influence of biomimicry, industrial symbiosis, cradle to cradle. In continuous feedback loops technical and biological cycles. In nature, the concept of waste doesn't exist. Each component that ends its cycle becomes a nutrient or resource for a new cycle. This is what circular economy is all about, to introduce you an outline. One of the great challenges of our region, in addition to the pressing environmental issues, is the human sphere. The high rates of inequality, poverty, lack of opportunities. The circular economy is a new economic model that breaks with the linear model. It's also an opportunity of sustainable development. Mada say in their presentation. The circular economy is, we can consider it, or we should consider it, not as an end in itself. It is a way to meet the goals of the 2030 Agenda, the Sustainable Development Goals. Returning to the issue of the social dimension, the necessary territorialization of the circular economy does refer to us to an effective use of resources and the design of the circulation of flows, or the flows of material or resources. This approach would allow us, for example, opportunity to generative, innovative business models of new jobs from new services, for example, to reuse, to repair, and generation of new skills. And how to prioritize the actions for a circular economy plastic. First, with the detection, identification of unnecessary and problematic plastics, avoiding the leakage of plastic into the environment and their negative externalities, decoupling the production of plastic from fossil fuels, like your program, supporting innovation in the upstream with new materials, new models of responsible consumption, with reuse of packaging and reverse logistics, for example. We need to change production and consumption patterns. So, what can be the potential contributions of quality infrastructure to the circular economy of plastics? For example, from this graphic, where we link circular economy with the life cycle perspective, we find some instruments such as metrology to measure quality and material flows, a standard for new materials or secondary raw materials, accreditation system for biomaterial certifications, labeling, laboratories for analysis at the end of life in their biodegradability or compostability. Okay, this has been a very synthetic overview of the way we are working and contributing from our plastic work group to the Kaburek program of the infrastructure quality for circular economy. I will be happy to answer any question if you have. Thank you very much.
Thank you, Gabriela and Madha. So just to let you guys know, we're in the process of establishing a national mirror committee for the circular economy. And we invite any of the participants who has an interest in the circular economy to contact myself or Adrian. We'll leave our contact emails in the chat. What we're trying to do is to enhance the participation of a developing country like Trinidad and Tobago in the development of international standards for the circular economy. Our national mirror committees would be the conduit for us to get the technical experts together at the national level and provide that feedback into the international standards development process. And we greatly appreciate the inputs from Madha and Gabriela, because we're also doing the regional work as well. And the Kaburek project is one of our main project initiatives for this financial year. So thank you, Madha and Gabriela. I now turn the session over to Dr. Okamoto. And Dr. Okamoto has been present with us in 2019. He would have done 2 workshop sessions with us on the topic of biodegradability and compostability. He's an expert in the area, and he has his own consulting firm, Green Bottom Line, that focuses on sustainable materials and packaging development, commercialization, testing, and certification. And he is also the chair of the ASTMD 2096 subcommittee that deals with biodegradation and bio-based standards. I would like to note that our session is supposed to run from 9 to 11, but we'd like to extend today's session so that we can get through the very salient points. I'm seeing a lot of technical questions in the chat, and we appreciate the feedback that we're getting. And Dr. Okamoto has been assisting us in disposing of the comments that we have already received. So on that note, I turn the session over to Dr. Okamoto to take us through some of the key aspects of the standards that we need to cover: biodegradability, compostability for Trinidad and Tobago.
Thank you, Nadita, and thank you everyone and TTPS for inviting me to be here. So I've been asked to go through and just do a quick overview of some of the content that was presented back in 2019, December 2019, and also to address a few other questions that have come up previously. So we'll just go into that. So the outline for today is to go over some definitions again, what industrial composting is and the standards associated with it. You've had some introduction to it from earlier presentations. Home and backyard composting and how it differs from industrial composting. Other biodegradability types, environmental claims, and solid waste management. Just some notes on solid waste management. So to go into definitions, when we say something's degradable, it just means it breaks down. And there are two ways it can break down. One is environmentally, which means that it leads to microfragmentation. It does not lead to full biodegradation, which requires biological breakdown into carbon dioxide or methane and water. And this is biodegradation caused by microbes, bacteria, etc. So biodegradation is a type of degradability, or biodegradability is a type of degradability. Compostability is a type of biodegradability. So biodegradability and compostability are not equivalent. Compostability, as shown previously, breaks down under controlled conditions of heat, moisture, oxygen, and bacteria. And there are various types of compostability, including industrial, backyard, home, and vermicomposting, which is composting by worms. And the solid that is generated is called compost. So how are they all interrelated? If you look at the big box being degradable, biodegradability is a subset of degradability. And then there are different types of degradability on its own. You can be photo, due to light, hydrolyzable, oxo, due to oxygen, soil, landfill. And then you can have equivalents under biodegradability where you go fully to your carbon dioxide, methane, and water and compost. So you can be anaerobically digestible, water biodegradable, compostable, soil biodegradable, landfill biodegradable, and so on. One of the definitions, oxidegradables, it degrades with oxygen, but it's often used for those that degrade by UV or light or other environmental means too. And landfill degradable degrades in a landfill. Typically associated with oxidegradables is the term. With the term degradable, it does not go all the way to carbon dioxide and water. And we'll get to what the requirements are for being considered biodegradable. At this point in time, none actually meet those definitions. So talking about the circular economy by Gabriella and Mada. If we look at end-of-life hierarchy, we all know reduce, reuse, recycle, or mechanical, chemical. The top choices for the circular economy or for carbon reduction or carbon cycling. So reduce, reuse, recycle. And then there's biodegradation, waste to energy, and then landfilling. If we were to actually look at this in a loop method, reduce is really a zero loop. You're not using it, therefore you don't have to try to recover the carbon that you use to actually produce something because you didn't use anything or you did use less. Then you reuse. With mechanical recycling, you get the material. With chemical recycling, you get the chemical back. So you break the material down to more of its chemical components. Biodegradation generates carbon dioxide and methane, plus it generates compost. Waste to energy generates CO2. And in essence, what each of these does is the bigger the circle, the more energy and the amount of work is required to get it back to produce a product again. So you can see where biodegradation fits in. So reduce, reuse, recycling, and then biodegradation. Biodegradation is good when you're talking composting and other things like that, but we also have to remember that in the grand scheme of things, reducing your material use, reusing your products, recycling your products, your materials, all precede biodegradation. But sometimes those are not possible to be done, which is why you start discussing things like biodegradation or composting and so on. Just to throw in there, the term bioplastic comes up often. It is a split definition, which is very difficult for a lot of individuals to understand. This is an internationally accepted definition. A bioplastic resin is a partially or fully bio-based and or compostable or biodegradable material. So when someone says they have a bioplastic resin, they have to tell you, is it because it's bio-based or is it because it's biodegradable? And the important part about that is that bio-based does not equate to biodegradable, and biodegradable does not equate to bio-based. Bio-based just tells you what the carbon source is for the material that you're looking at. Biodegradability is based upon the chemical structure of the material. So there are plenty of materials that are biodegradable or compostable that are produced from petroleum, but there's some that are also produced from bio-based materials, and there are some that can be produced either way. There are also plenty of non-biodegradable materials that are produced either from bio-based sources or from non-bio-based sources. So the two are not equivalent. And so when we discuss any of this, we're talking only about biodegradability, and bio-based content really doesn't have much to do with this unless you want to talk about carbon cycling. So generally, why do we compost? It increases food diversion from landfills, reducing the trash going to the landfills, and it produces a beneficial product that can be used for gardens, flower beds, landscaping, bioretention, rain gardens, roadside erosion control, and a number of other things. This helps to put some nutrients back in the ground from whatever's been composted. And there are a number of different industrial compost process types, from windrows, which is the most common, and then you have in-vessel, where you cover it with like a Gore-Tex cover. These tend to be the most sophisticated ones, where they have monitoring equipment built in. They have piping running underneath to blow air into the pile to keep the oxygen in there and keep it aerobic. They also have water injected on top as they monitor the moisture content and so on. And then you have aerated static piles. Aerated static piles are probably the easiest to operate. These are generally piles that sit for a certain amount of time, and then they're moved over to what is called a curing location. You have mass bed, and you also have tunnel. Tunnel is one where you, in essence, push material in from one end, and as you push material in one end, you start to push material out the other side, and your tunnel is based upon how long you want it to be in there to create your compost. So there are a number of different ways that you can actually run an industrial compost process, some that are moderately inexpensive and some that are more expensive to operate, depending on how much control you want to have and how much monitoring. Your feedstocks, I mean, I think most of you know what can go in there. Most of your food waste, most of your packaging that is compostable, as well as your primary is going to be your yard waste, plants, untreated wood, and so on. What many people might know, if you run compost piles, or your brown and your green, and you keep a ratio of that to keep your carbon and nitrogen content ratio the way you want it. So what are your typical industrial compost conditions? They are run under thermophilic conditions, which is from about 52 degrees C to about 70 C. In this range, you have a certain type of bacteria that actually lives and breaks down the plant matter and so on. You maintain about 50% moisture. You get it too dry, it will heat up too fast and you'll get spontaneous combustion. You get it too wet, then you affect the ability for the microbes to actually grow. It has to be aerobic. You have to maintain your oxygen running through it. And typically you have what is called your stage 1 composting, which is 28 to 90 days, with an additional curing, which is more at room temperature, for up to 90 days to finish your biodegradation process. Your initial carbon to nitrogen, brown to green ratio is about 30 to 1. You can start from 22 to 1 up to like 40 to 1, but most start somewhere around anywhere between 25 to 1 to about 32 to 1. And you end up with something that's about a 13 to 1 carbon to nitrogen final ratio. So what you're doing is you're actually evolving your carbon dioxide, which reduces your C to N ratio. The running thermophilic, at least for the first 3 to 7 days, is very important because that kills the vermin and your bacteria and viruses associated with what may be coming in. Additionally, that temperature also tends to deactivate your insecticides, herbicides, pesticides, other chemicals that might have been used in agriculture. So it's important to run those conditions. And because you've killed the vermin, the compost generated in industrial composting operations is safe to put onto your food crops and so on for adding nutrients back to the soil. So why do you test and specify? To prevent something like this being left behind with all the uncompostable paper and plastic waste. In the standards that were previously presented, ISO 17088, EN 13432, ASTM D6400, a lot of the parts are very similar between the different standards bodies. There are some minor differences between them. And a couple cases not so minor, but the 4 parts are: you must know your metals content, which takes about 2 to 4 weeks to determine. You do a disintegration test, which is 84 days. One requires 90, but 84 days is typical. Mineralization, 180 days, which is the biodegradation phase testing. And then you also have to do plant growth testing, which takes about 4 weeks. Should be noted that ISO 17088 has done something that is, I think, very good and very important. They've added in an earthworm toxicity test, something Australia had, but because they were the only ones, it was made optional in Australia, but ISO 17088 makes it mandatory. And most likely ASTM and SEN will probably add the earthworm toxicity test to this too at some point in time. Total time is about 8 months to do all this testing. I just want to go over really quickly that there are 6 types of ASTM standards. This is also true to a large extent for ISO and for SEN. we're not going to worry about most of these first, the 4 on this slide. So they're classification, terminology, guide, and practice. The main thing to understand is that these do exist. We will talk about one guide later, but it is merely a compendium of information of options, but does not recommend a specific course of action nor a specific test result that is required. There's a test method, and this is just a procedure that produces a test result. You cannot pass a test method because there is no pass-fail requirement. So D5511, D5338, or any of those are test methods for anaerobic digestion, for industrial compostability. You cannot pass those tests. You can only give your results because there is no pass-fail.
Mr. Okamoto,
Yes.
I am so sorry. My name is Giselle Tejero. Sorry for interrupting. It's because you're going very, very fast on the numbers that you're giving for the standards, and they are not in your presentation. Would you mind repeating them, please?
I will go over those standard numbers later.
Okay, thank you so much.
Sorry, those were examples, sorry. Specifications are an explicit set of requirements to be satisfied by material, product, system, or service. So only specifications can provide requirements for terms such as compostable or industrial compostable. And the standards for ASTM, SEN, and all were presented earlier. We'll go over those specifically in a few minutes here. So ASTM has ASTM D6400, which is a single layer plastic product, typically used for non-plastic products. So in other words, molded fiber, and for other things too, paper products and so on. And ASTM D6868, multi-layer product with a natural fiber layer, but is also typically used for any multi-layer product. This is different than EN 13432, ISO 17088, and so on, which tests a product for biodegradation on the full structure of the product. In other words, no matter how many layers, it's all tested for biodegradation together. ASTM D6868 requires biodegradation of every layer to be tested independently. What ASTM D6868 does is prevent companies or product manufacturers from taking a paper product and putting on a very thin layer of polyethylene. And because the layer of polyethylene is very small, it passes the biodegradation test. But what is left behind is the polyethylene layer that does not biodegrade. So ASTM D6868 is very specific that every layer must be biodegradable, no matter what its coating, its percentage of the product is, to prevent microparticulation of the layers. EN 13432 is similar to D6400, except it does not have the layer exception for 6868. EN 13432 was actually developed by the same individual that developed ASTM D6400. And he did a great job in getting this all through back in the mid-90s. But ASTM D6868 came along a few years after that, based upon some technical information that was available. So what is the requirement for all this testing and for the specification of ASTM D6400? Disintegration must be greater than or equal to 90% through a 2 millimeter sieve within 84 days. You test this by ISO 16929 or ISO 20200. If you're going to do additional testing in the field, you can use other tests like modified D5338, which used to be accepted. It's just depending on how much you want to spend on the disintegration testing. So ISO 16929 is at 35 plus liter size, and ISO 20200 is at the 5 to 12 liter size. ISO that's modified D5338 is 2 to 5 liters. All these tests get similar results when you do a side-by-side. ISO 16929 does pass many more products than the smaller scale test does. So it's just a caveat that results, though many of the products give similar results in all three, if there's a difference, the larger scale tends to pass more products for disintegration. For mineralization or biodegradation, you must have greater than or equal to 90% converted to carbon dioxide and or humus within 180 days. This test is by ASTM D5338. In a previous presentation, you saw some other numbers for this test for ISO and for SEN. They're actually all very similar. They're all based upon ASTM D5338. It should be noted the and or humus is in parentheses because there is no accepted way for measuring how much humus is generated in the test. This is, right now there is a working group within ASTM to actually determine how to measure how much humus is generated. We'll have to see how long it takes for that to develop. It's based upon measuring specific items that might be, that are generated when you generate humus, but it still needs to be proven out and so on. So right now, the idea is just generate the carbon dioxide. There's a lot of interest in using lignin for these kinds of products. Unfortunately, lignin generates humus. We don't know how much. And so lignin containing items often fail this test or this particular requirement. But, and that's one reason why we're going back and looking at this, but there is no technically accepted way today for being able to determine this on a consistent basis. So plant growth, you have to have greater than or equal to biomass and germination rate of control plants. That's on both monocots and dicots, and tested by, this is by a international standard OECD 208. And I mentioned earthworm toxicity, a similar type testing, and that one is actually by an OECD 207 test method that's been out there for several years also. Your metals content must be less than or equal to 50% of the national regulations for heavy metal content in sludge or compost, unless you have a regulation specific for heavy metal content in compost. And there's a new amendment that was just passed for the ASTM standards 6400 and 6868 for Canada, because Canada has a specific regulation for that. And Trinidad and Tobago might also, so there's also that, you can do that too. There are a lot of additional requirements, and I don't really need to go into each of these. They're here just for those who are interested. One of the most important parts to understand is no preconditioning allowed. That is, you cannot do environmental preconditioning and call yourself industrially compostable. The main idea here is that you don't know how long the product is going to be out in the open environment before it goes into composting. And you would hope it's not been in the open environment, because that means most likely it was littered. You're going to go straight from your kitchen to a organics recycling or a compost pickup to the compost pile. Therefore, there is no preconditioning. There's no exposure to light, no exposure to oxygen of the right type, or other conditions like that before you put it in the compost pile. And some more preconditions. But anyway, ASTM D6868 is similar, except it says that every layer must also pass biodegradability. And we'll skip this part. Why is ASTM D6860 in existence? There was an eco-cycle study performed at Woods End Laboratories in Massachusetts back in 2016 with a follow-up in 2018. whether you're using paper plates with an acrylic, thermoset acrylic coating, or you're using cups with a thin polyethylene coating or whatever, in a compost pile, you will leave behind microplastic particles from the plastic coatings. And therefore, it is critical that when you use paper products, that they're using a compostable coatings, compostable adhesives, and other things like that, or else they will be left behind. Adhesives and coatings are plastics, but they're a different type than most think about. There are thermosets versus thermoplastics. Thermosets are plastics that are generated in situ. Thermoplastics are ones where you receive pellets and you then turn them into products. You can also do field disintegration testing. And this is actually in the process of being turned into an ASTM standard also, where you actually test in an actual compost pile. You take the products, you bury them in the middle of a compost pile, and you have it go through the standard composting process and so on. Why do we have this? The lab tests are great, but I like to think of them as a screening method for disintegration. The field test is the actual in-use test to determine if they actually work. And one of the reasons why field disintegration is important is that a lot of products that pass the laboratory disintegration test do not pass the field disintegration test. For industrial compostability certification, you have a number of organizations around the world. I just give here 3 from North America and 2 from Europe. Biodegradable Products Institute, which is the most common in North America. Compost Manufacturing Alliance, which is actually run by industrial composters. And they require field disintegration testing. They've been doing this for 20 years at this point in time. But they do field disintegration tests and will tell you which type of compost pile your product or a product can be used in, whether it's the aerobic, the standing pile or the in vessel or a windrow, because they all have slightly different conditions upon which they operate. And they may treat what happens with products in the compost will differ depending upon the conditions of those particular piles. The Canadian Compost Council also, or the council, it's actually the Compost Council of Canada, actually has certification too. There are very few materials that are actually certified through them. There's only 16 at this point in time. Europe has Denserco, and TUV Austria, Belgium, which actually used to be Vinso. There are additional requirements, fluorine content to prevent PFAS and other things like that. You have FTIR scans, you have manufacturing location process line has to be declared, your formulation to the certification agency, material and product audits, and then you must recertify and retest occasionally every 3 to 5 years. There are fees for all this certification review and license too. Certification does not apply to importers and distributors. It is dependent, it is solely the function of the producer, because the producer is the one that is responsible for the materials that they use, the process they use, and everything else. Home backyard composting. How is it different from industrial composting? In industrial composting, we said you have to be thermophilic. You can from about 52 to 70 degrees C. Home and backyard composting is not as well monitored and regulated. Therefore, many of your backyard and home composting occurs at much lower temperatures than that, often in the range between about 30 and 40 C. This actually puts it into a different bacterial microbiome environment for the composting operation. and that is a mesophilic range. It's a different set of bacteria. And therefore, you have to test for the compostability in that lower temperature profile or process conditions for composting. Right now, there really isn't internationally or set standards for mesophilic testing for both biodegradation and disintegration. They are sort of out there because there are both Denserco and TUV Austria do certify for home compostability, but it is not internationally recognized of the methods that are used to determine that certification. The biggest issue is that when you do this testing, you must measure the temperature in the pile, because the temperature inside the compost pile, that's important as to what bacterial component you have. Right now, the test method, they measure the outside temperature of the pile, the temperature around it. That doesn't tell you, you can be at, 15 C outside, but the pile could be anywhere from 30 C to 70 C. But depending upon where in that range you are of internal pile temperature will tell you which bacterial environment you're in. So I like to differentiate between home and backyard composting because of a lot of the equipment that's sold on the web. Home composting is in the home. And a lot of times it's just bins that are put by the sink. And honestly, it's just food in there. So really it's food rotting. There's no real composting going on. Backyard, I'd like to call outside the home to differentiate it from what you do inside the home. In backyard composting, you really, if you want to do it, you must say that a material that is backyard compostable, it's been tested under both mesophilic and thermophilic conditions to make sure that no matter how the backyard compost system is run, that that the material or product will break down in that backyard compost pile. It should also be noted, as stated before, mesophilic conditions, unlike thermophilic conditions, do not kill vermin. They do not kill the bacteria and viruses, and do not always deactivate the pesticides, insecticides, and herbicides, etc. Compost from a mesophilic backyard compost are not to be used for food crops. That is unless it's known it was running on the thermophilic conditions. There is a standard for testing for biodegradation in mesophilic conditions. This test method is rather tedious, and we are looking at how do you improve it to make it easier to run and to make it easier to run. Other biodegradability types. Just a note, a material or product may biodegrade, but the material or product is not biodegradable unless it biodegrades to greater than 90% in a specific environment within an acceptable period of time. Why 90%, not 100? Because there is variability, there's error in the test method and the measurement methods. The exception is landfill biodegradability is accepted at 60%, since microfragments are contained, hopefully, within a closed environment. There's also open environment biodegradability of soil and water for products intended for use in soil, water, not for addressing litter. In other words, it's for products like ag film, which may need to be on a field for a year. But then does that film, if it's on the field, in the soil, does it actually then biodegrade in the long run? Soil biodegradability requires water biodegradability because your first step is disintegration, which makes particles. The particles could wash off out of the soil into water. Therefore, soil biodegradability requires water biodegradability. There's a test method for soil biodegradability. And you see the method here. I'm not going to go into details. And also for water biodegradability. There is a specification for water biodegradability also. It has been withdrawn and is being rewritten with more stringent requirements. The old standard has been around for 20 years. It is still used. That is what is used as the standard for water biodegradability by DINSERCO and TUV Austria, Belgium. But we are in the process of actually making it much more tough to actually pass this standard. Anaerobic biodegradability, there are two types, anaerobic digestion and landfill. Landfill generates methane. Methane is, or both anaerobic digestion generates methane. Methane is worse for global warming potential than carbon dioxide. In the short term, it's 80 times worse, but because it breaks down faster than carbon dioxide, in the long term, it's 34 times worse, but it's still much worse. There are standards. These are test methods. These are not specifications. It's dry anaerobic digestion test method for, so in say a vessel where you have very little water, because these are anaerobic, they tend to have to be in vessels. You know, how long do you do the test and so on? You can see there are other test methods too. For landfill biodegradation, you have a few different ones. You have 5526, 7475, and then you have a guide 6954. One thing to note, in the definition, in the title for both, for these standards, it says accelerated conditions. So if you test it out and it takes 4 years to go to 90% biodegradation in anaerobic conditions, how long does it take in an actual landfill? At this point in time, the correlation is not known between the time in these accelerated tests versus the actual landfill. You've already gone through claims. I'm going to skip over this part pretty quickly. The US Federal Trade Commission, as well as Canada's Trade Commission, and have guidelines for the use of marketing claims for environment. Europe is working on one too. Theirs is a much more generic. Out of Europe, one thing to note, biodegradability and compostability are still used interchangeably and allowed. That is not allowed in Canada and the US, and I suspect Trinidad and Tobago's Bureau of Standards is setting the same standard there too. The claims must be based upon data. Testing and certification is best if not by non-affiliated third parties. And you must avoid unacceptable terms as stated previously, like environmentally friendly, green, and biodegradable. And you may need to qualify the claims for the time to industrially compost, the availability of composting, and so on. And lastly, for landfills, the Trinidad and Tobago landfills, I've been, as I believe they are not lined underneath. They're covered with organics, and they accept all solid waste. This means that because they're not lined underneath and because they're only covered with organics, they tend to stay aerobic and may at most be partially anaerobic. So saying that you're going to have anaerobic digestion in a landfill in Trinidad and Tobago may not actually hold true, since it is not actually fully covered to make it go anaerobic. Best practices for landfills. By far, I am not an expert on landfills. Is that you tend to line underneath, you cover with an impermeable membrane like big plastic or concrete, and a life cycle of a landfill is aerobic until covered, anaerobic for 5 to 10 years, and then dead thereafter. It should be noted that because of the methane that is generated in an anaerobic system, in many places you're required to pipe so that you make the methane come off and go to some place where you can collect it. It's not terribly efficient at this time, but at least it's better than nothing. Industrial compost facilities, no standard legal requirements, not to be combined with landfills. There are best practice guidance and certifications available from the US Composting Council and the Compost Council of Canada. You do have to have site considerations and operational considerations. And then what are the costs for an industrial compost? It depends on the type to be implemented. The same area can be used for 4 to 8 cycles per year. The base costs include a concrete base to protect groundwaters, grinding equipment, sieving equipment, bulldozers, compost and process monitoring. However, you do get savings. You divert 40% of your organic waste from landfills, which reduces your land required for landfills, and you can sell the finished compost. And just a note on recycling. Recycling, there's not enough population in Trinidad and Tobago to justify. You can do the initial separation. However, what do you do after separation? And most likely that requires shipping to other countries for further processing. Just a note here, there is a workshop coming up in a couple of weeks with ASTM that spends 12 hours going over a lot of this and more. And thank you. And when you get this, there's also an addendum on what are some industrially compostable materials too. Thank you. Hopefully I didn't overrun too much.
Thank you, Calvin. So we can move immediately into the question and answers. So there are some questions in the chat so that we could start taking a look at them. Okay, so I'm just scrolling through the questions, but we will also invite the participants to raise their hands and unmute. Okay, so there are just some questions. There was one about, is there biodegradable material available to mitigate oil spills in Trinidad and Tobago? And Dr. Okamoto, you answered that. And then there's one from Vandana Singh Bodges. Are laboratories available locally for testing product characteristics? And the answer for that is that there is limited testing facilities available locally. So it is something that we have taken note of. So Dr. Okamoto, do you want to comment on the availability of the testing infrastructure required to support this particular standard?
Sure. There are a number of approved laboratories around the world for the various certification agencies. The one that most people know is OWS, Organic Waste Systems, out of Belgium. However, they tend to run the larger scale and therefore tend to cost a lot more than others. There are labs in North America. There's three approved ones in the US. There are also 4 other labs that I'm aware of that are starting to get themselves set up in Canada and the US for doing this testing. They tend to run the smaller scale, the 20200, or even the modified D5038 test. And it makes them also much less expensive to run testing there. If you're producing your own products, you will need to do the testing, but if you want to import products, that is actually going to be the responsibility of whoever you're importing from and produce the product. So the testing for a product, if it's a single layer, can cost $12,000 US. If you're running a modified D5338, or if you're running a ISO 16929 disintegration test, which is really the only big difference, that'll run you near $50,000 to $60,000 US to run a test like that. It's so much bigger. It requires so much more sample and so much more work for them to actually do it. Those vessels tend to go into a heated room rather than being in a heated chamber. So, I mean, we can set up lab testing in Trinidad and Tobago if TTBS and other organizations want to do that. It doesn't take a lot of space to do this. And there are organizations that might be willing to help you set those up, or I can arrange for that and so on.
Thank you, Dr. Okumoto. I'll go to the next question. Can you elaborate on ASTM D5511 and why this test is not listed or used, please?
ASTM D5511 in the presentation is an anaerobic digestion method, test method. We are talking about industrial compostability, therefore ASTM D5511 is not germane to this particular discussion.
Okay, thank you. I'll go to the next question. And are there any plans for traceability for the raw materials for biodegradability? For example, PLAs made from palm oil and some of the farming sources can be less than good for the environment.
Right now, that is largely left to the suppliers to provide that information. But like PLA from North America is actually made from corn. PLA made by NatureWorks and Total Corbion in Thailand is actually produced from, I believe it's manioc and sugarcane. I think you call it manioc in Trinidad and Tobago, tapioca, cassava, all the same thing.
Cassava.
Cassava, okay. I can't remember which parts of the world call it what.
So there's another question, and it deals with the definition. So the definition of biodegradability is defined in terms of aerobic and anaerobic. Why then does the proposed standard deal solely with the aerobic process via industrial composting?
Because composting is a type of biodegradability. And as explained further, the only real standard I think in discussions with TTBS is that we want to focus on one way now, and we can possibly introduce other ways for biodegradation to be acceptable down the road. Industrial compostability has the most standards associated with it, as given by several of the presentations today. And industrial composting is also a process that can be set up and controlled. Whereas when you start talking about soil and landfill and water, right now those are not really well controlled. They're not intended to be for litter. They're intended to be for products used in the soil and so on. So like a food service item is not intended for soil. It's not intended for the water, and should not go in a landfill. You could use anaerobic digestion, and there are things that can be done. That is a controlled process also that is man-made. They tend to be smaller, though anaerobic digestion is also a well-known industrial process. What comes out of anaerobic digestion, though, is called digestate. It is not compost. It needs to go through another phase of composting to actually become compost. So what typically happens, digestate can be put out on a field, but it is not especially able to go on a field, go into food immediately, at least by US and Canadian standards. But what you can do is put the digestate into the curing phase of a composting operation to make it compost. Therefore, even if you're going to do anaerobic digestion and you want to use the digestate coming out of that, you still need a composting facility.
Thank you, Dr. Okumoto. And I guess related to that is, you would have touched on this as well. Why is the proposed standard only focused on one type of biodegradation?
Because we have to start somewhere. At least that's my opinion.
Yes. So yes, you'd have touched on the differences required for the composting biodegradation. And similar questions again. The 3.2 defines the term biodegradable, and as with other non-compostable materials, but there are other disposal environments in which the packaging will end up. So these other environments are excluded in the present standard. This provides an incomplete solution to the pollution issues.
It does, but also when we talk about littering, that is a human problem. It's an education and habit issue that needs to be addressed, that we all understand that needs education, needs ways for the public and industry and so on to actually know how to address. Unfortunately, any of the standards, even for soil and water, do not address litter. They're not intended to address litter.
Okay, so I'll go to the next one, and it touches on what you mentioned in terms of education sensitization. Are there plans to educate the public to understand the need to separate the plastic types and which are not for burning, for example, ABS and PLA, and separating the different types if in the future a recycling system is introduced? So I don't think that is a comment, that is an issue that we have to address at the national level. And
Yes,
I would
thank
say,
you.
yes, there's a need for education. I'll go to one of the technical comments now. In 421 Note 3, the landfill is listed as a disposal environment, but this standard does not provide a solution for landfill. Same for accidentally discarding in the environment. And these two examples are critical when discussing pollution. So similar to the question above.
Understood. And Radu, my opinion on all this, sorry. Radu is a member of ASTMD 2096 also.
Yes. And okay, so a question from Vandana Singh Bodges. Please, can you clarify what is the brown part of the brown-green ratio?
Oh, okay. Yes, sorry about that. In essence, the brown is your brown matter in compost, which would be your limbs, your branches, your dead matter, your brown leaves, and so on. Your green matter is your green grass, your green leaves, your live plants, and so on. The green tends to have a higher content of nitrogen, and the brown tends to be mostly much higher content of your carbon, which is why, before you could, rather than having to measure specifically, you say you want to hold to some sort of mix of brown and green.
Okay, so again, another query from Radu. If composting is the only environment to discard the plastics as per the standard, has TNT prepared and implemented a collection scheme of the compostable plastics? Otherwise, the plastic waste stream is compromised. The compost facility cannot run the compost process. So I think, Dr. Gumuzo, you can comment on that, but this is a national level discussion in terms of solid waste management, and a bit related and very important for the implementation of the standard, but it is a national level issue that we need to deal with. But if you wanted to comment.
No,
okay.
You've said it properly. It's a scheme that you all have to set up.
Yes. And Cyan Coffee Young should have addressed as well the comment from Vandana about the green-brown ratio. And again, a comment from Radu. As this standard considers a compost as a single disposal environment, has TNT developed the capacity of composting to cover all the plastic material that will be generated immediately after the implementation of this standard? I will just comment as TTBS. And while we're developing the standard, it also means that there are many other parts of the state agencies and ministries that will have some responsibilities to enable a proper solution. So we're dealing with the technical requirements required to address the issue of biodegradability, compostability, and the appropriate test methods and parameters. But we do recognize as a country, it is a holistic solution that is required. So we would not want to put a direct answer to this, but the discussions have to continue at the national level. And there's a comment from Ray Lewis regarding the list of standards, and we will make the presentation available. A comment from Radu again. In order to deal with plastics that may end up in landfills or discarded in the environment, the ASTM D6954 should be included in this standard. And he gives the name. Standard for plastics, the biodegradable, the list of. So basically, should ASTM D6954 be included?
Not for industrial compostability. Industrial compostability does not allow preconditioning. 6954 is a standard that requires first the 3 steps, but it doesn't tell you exactly how exactly you do a step. But the first step is that you do some sort of environmental conditioning, followed by testing for composting or anaerobic digestion or something else like that, followed by some sort of toxicity testing. This test method is not a test method. This is a guide. There is no requirement that needs to be met. It just gives you a set of steps that you need to follow. And yes, it could possibly be used for landfill biodegradation, but we're not talking about that here with this particular standard.
Okay, so again, a comment on which laboratories in Trinidad and Tobago are accredited to perform the required tests for biodegradation and compostability. We would have touched on that earlier, so I will just state that there is a need to consider what level of testing infrastructure is required in the country, and that is something that TTBS will consider as a supporting mechanism for the implementation of the standard. Another comment, a query from Radu: in a compost batch, what is the maximum percentage of compostable plastic material that can be added to that batch?
Different industrial composters have set different limits. Most tend to be somewhere between 1% and 10% as the maximum percentage.
Okay. I'm going down. There's a comment from John Robertson regarding recycling and the bins required for composting. So there's general agreement that some level of composting needs to be done at the home level. I think you'd have covered what are some of the technical requirements there. There's a question from John Robertson. I guess he's asking, does the standard include PLA class 7 compostable plastics?
Yeah, if you're talking the class 7, that is for sortation, that is the sortation code for plastics. Class 7 is other. PLA is included in that, because whether you're using that for recycling or not, it doesn't really matter according to this. How you classify it doesn't matter. How you, for recycling sortation, doesn't matter how you classify for this.
Okay. A query from Vandana: can compost generated under mesophilic conditions be treated to ensure that it is safe?
Good question. I don't know the answer to that. I've heard some trying to treat it by UV or other things like that to try to kill to make sure they've killed the bacteria and so on. That I don't really know. There's probably a way.
Okay. Just a query from Giselle. Will TNT be accepting test results and certifications from other countries? And I'll say that within the compliance clause of the proposed standard, it does consider accepting results and certifications from other countries. And that is significant given that there is a limitation in terms of the testing infrastructure within the country now. A lot of our products are imported, so there has to be a level of acceptance. This part of what we call the national quality infrastructure and relying on test results, test certificates, and certification marks from other countries once they have satisfied the criteria of TTBS. I will go to the next question, and this is from Dwight DeLeon. Similar to the questions before, why are industrial composting facility the only facility being considered? This is Trinidad and we only have landfills. It is not sufficient to say that we are only dealing with industrial composting facilities. So Dr. Okamoto, you'd have touched on what is possible for the country at this time.
Landfill composting is not a thing. And no one has set up composting in a landfill. Plus, if you compost in a landfill, you cannot recover the compost for use down the road. You've lost the material. The reason to compost is so that you generate compost for use in fields and so on. But if you do it in a landfill, which has never really been proven, you don't generate usable compost. If you're going to be doing biodegradation in a landfill, if you do it in a landfill that is typically lined and closed, it is anaerobic, it generates methane. And methane generation, as stated previously, is much worse from a global warming potential. The only way that's been proven to actually prevent methane from being released from a landfill is to do a concrete cover, which is very expensive, with piping underneath, and then the piping runs the methane off to a methane capture facility that can then be used, where the methane can be used to run generators and other things like that. But unless you're willing to spend that kind of money on a landfill, landfill compost, landfill biodegradation is not recommended by most from a global warming potential.
Thank you, Dr. Okamoto. I see Barry Factory, a member of our National Merit Committee, has raised his hand. So Barry, you can go ahead.
Hi, good morning, everyone. On the question Giselle asked concerning the certifications, I was wondering if Dr. Okamoto could expand a little bit when it comes to certifications, because we've been seeing a lot of different certifications from various regions, various certification bodies entering not just Trinidad and Tobago, but the region. And for an industry standpoint, could you give a little more input and insight into that so the industry would know what to look out for and what to expect and what certifications they should be using from which bodies?
Sure. From an industrial composting certification standpoint, there are several that do it. You have Greenpla out of Japan, you have Taiwan's, you have China's, you have Australia's. Most of them follow EN 13432 or ASTM D6400, most on EN 13432. So you have Dinserco, and it should be industrially compostable. And then also you have OK Compost from Dinserco, that is from TUV Austria, which should say OK Compost Industrial if you want industrial composting. BPI, Compost Manufacturing Alliance, they all have slight differences, and depending on how the final standards set by TTBS will determine which of the certifications you can accept. All of them are similar for single layer products, but when it comes to multi-layer products, because of the difference between ASTM D6868 and EN 13432 and ISO 17088, will determine which of the certifications you can accept for multi-layer products. That's where it gets confusing, unfortunately. And once the final standard is set, we can provide which certification agencies for which types of products can be accepted.
Okay, thank you, Dr. Okamoto. Barry, I hope that answers the concerns. So there are lots more comments. As I indicated, that we will appreciate maybe a half an hour of your time again. And I will go in reverse order now, right? So there's a comment on education. We agree that it is a great way to start. So that is a national level discussion. We thank Mr. Trotman. He indicated that he had to leave. In response to Giselle, in terms of the standards, we will provide the presentation and it will have the list of standards that need to be considered. We also have a list of the reference standards in the draft standard, which will be updated as well. So Giselle, we commit to providing you with the presentation and the information requested. We thank Madha and Gabriella for their support in terms of the circular economy. And there's a question from Vandana Singh Bodgers, and she wanted to confirm the due date for the provision of comments on this draft national standard. So just again, to put things into context, we have completed the public comment period and we received a number of comments, a lot of technical questions, and we will allow possibly 1 to 2 weeks for any further submissions. A lot of the comments that we have received have also been echoed in the chat. And it also requires a lot of discussion to take place with the relevant ministries and state agencies in order to have a holistic solution. Having technical requirements in this particular standard is one part of it, but there needs to be a lot more discussion at the national level. So Vandana, we will extend the comment period by 2 weeks for the submission of any further comments based on what we have heard from Dr. Okamoto today and in terms of the proposed changes we'd like to make. And again, there's a comment from Mr. De Leon, and he wanted to get, Dr. Okamoto, your opinion. So he said, please explain why we should start passing standards for facilities that we do not have and there's no plan to attain, while leaving out standards and test methods that would apply specifically to us. And I guess he means for Trinidad and Tobago, our national context.
And I'm following the lead of TTBS and other bodies within Trinidad and Tobago as to what is desired. But your other standards do not actually pertain to Trinidad and Tobago either, because they are for landfill types that actually do not exist in Trinidad and Tobago either. Plus, you're trying to do something for the environment. And putting things into, just putting all this, say landfill biodegradability materials into landfills actually harms the environment through the generation of methane, and you don't get anything back out. You don't get the compost, you don't get anything. But the other part you're doing is that it is possibly a way to save money for Trinidad and Tobago by setting up an industrial composting facility, by not requiring Trinidad and Tobago to have as many landfills or to grow the landfills as quickly as they are growing at this time. Trying to stay within the existing infrastructure doesn't really help the situation of what is the goal for this particular standard.
Thank you, Dr. Okamoto. So I just wanted to, address the initial request that we have is to deal with alternatives to certain expanded polystyrene products that are being banned. Now, there's another comment. It does not prevent TTBS from undertaking additional standards that may be necessary in the future, because again, there's a comment about ASTM 6954. And it appears as though that there might be a solution, but we have to consider the problem from all dimensions. Will we be creating additional concerns? And it is not only TTBS that would take this decision, because we are also working with different ministries and agencies to provide a complete solution. The solution may not materialize in the short term, but definitely as we do medium term and long term plans, that there will be the possibility for additional standards. So while I look through the other comments and questions from the chat, I wanted to recognize Cyan Coffee Young. She has her hand up, and then Giselle. So Cyan, you could go, and then Giselle.
Thank you, Ladita. Good morning, everyone. My name is actually pronounced Shan, by the way, but don't worry about it. Everybody gets it wrong the first time. That's okay. My question is to Kelvin, really. I serve as a waste management educator, and that's my reason for being here today. And one of the things that I do is talk about backyard composting and try to encourage residents to adopt those practices as part of their whole thrust to be more sustainable. You mentioned that the compost created in backyard composting should not be used for food crops. So my question then, therefore, does it make sense to, in your opinion, to continue to advocate for people to do backyard composting? That's one. And the second question is with regard to the setting up of an industrial facility. So I've worked in waste management for about 17 years. And I have actually worked for the Trinidad and Tobago Solid Waste Management Company for a big chunk of that. So I'm very, very aware of our waste landscape here, our landfill processes and all of those things as well. In the setting up of the facility, would you say that it's best that that's done as a private-public partnership, as a government thing? Because I'm an action-oriented lady, so I like doing stuff. I don't like sitting down and waiting. So if it were that it can be done maybe on a medium scale rather than a large scale, is that something that you would encourage to be done? And do you think that, of course, the following the ASTM standards in terms of the final product would also be something that needs to be considered? So it's two questions. Thank you so much.
Thank you for those good questions. The first one, I encourage backyard composting no matter what, because you can use the backyard compost for your gardens, for other things like that. And if you're doing it for your own food, that is fine because you're used to your own bacteria, viruses, whatever. It's when you start to go to larger fields and things like that, go to the public for serving food, that's when there might be an issue. But also, if you do backyard composting and you are certain that you are actually at over 50 degrees, 52 degrees C for your compost pile, then you'll be fine. So if you measure the temperature in the pile and you're running thermophilic, go for it. You're great too.
All right.
It's just that for a lot of individuals, they just throw the stuff out in their backyard and they sort of forget about it. They don't know that they need to go out there and turn it occasionally. They don't know that they need to, just to make sure that it runs well.
And the good thing about it is at least I teach them that, so they understand that that they have to turn it, they have to give it, as I say, love, care, and attention in order for it to work. Otherwise, you're not composting. Yeah.
Yes.
All right. And question two.
And for question two, I don't really know what's the best way to get one set up, whether it's public, private, or public alone. I think that's something to be determined by TTBS and other agencies. But, you can possibly set one up, as you say, like a medium scale initially. We can go back and actually calculate how much food waste you believe is being generated. Packaging waste is going to be a small percentage of that. Packaging waste is being generated, and I believe I heard a comment last week, it was 40% for Trinidad and Tobago in a landfill. So we know how much is going in a landfill. We can calculate how much land and area is required for an industrial composting facility. and then determine, whether you want to go full scale initially or just do a small scale setup just to get used to it and then grow it over time.
That makes a lot of sense. That's what while you were speaking, that's what I was thinking, rather than just waiting for it to be large scale and that takes a lot of financial investment, it may be wise to look at some smaller options. But as one of the points Nadita raised is that a lot of these conversations are national conversations. And as such, we would have other players to kind of weigh in. But as an entrepreneur myself, I always look for ways of making a difference. And so that's why I wanted to ask you that. So thank you so much.
You're welcome. Well, one of the other things is that, do you want to make sure you have a facility on each island, so that it's readily available and accessible to everyone to just take their yard waste or lawn or, food waste or whatever to it?
Yeah.
And to make collection easier too, if it's on a national scale or whatever.
Thank you. We'll now move to Giselle.
Good morning. My name is Giselle Teixeira. I'm representing PriceMark today. I have 3 questions. The first one would be, do we have more or less estimate on when this standard would be enforced? That's one. And then the other 2 might be for Dr. Okamoto. One would be in regards to disposable paper products such as plates and cups. The ones that are specific for holding hot liquids like coffee, those always have this plastic layer you were talking about. And sorry if I don't have the terminology correct, but so I'm just going to call it plastic. This plastic layer, are those going to be, according to how the draft or the standard is written as of now, are those going to be completely banned? And if so, are you guys considering what will be the alternate products that we can use? I'm thinking, for instance, for the coffee, right? And then the third one would be, if I understood correct, and I might not have understood correctly, but if I understood correctly, some of the international standards and that are out there and that are probably accepted by other countries may not necessarily be accepted by Trinidad because of the landfill situation. And will we be clarified on which standards or certifications from other countries will be accepted? I'm deeply concerned with this because PriceMark operates in 13 countries and about 5 or 6 of them already have similar regulations, and they are all coming up with the same things, right? Standards and certifications. And my concern is, if everyone comes up with different certifications and standards, then it's almost impossible for a company like ours, which operates in so many different countries, to have these multiple certifications per product, specifically with the costs that Dr. Okamoto was mentioning.
Nadita, you want to take the first question and then I'll take the other 2?
So we are taking some time to go through some of the technical issues that came up during the public comment stage. Our intent is to complete this particular standard within this financial year. So I would have indicated earlier that we will give 2 additional weeks for comments to be submitted. And I should let all the participants know that there is a process by which a standard becomes compulsory before it moves into the enforcement stage. So we require approval from our TTBS Board of Directors. Then we're required to do a legal notice of declaration that is published in the Trinidad and Tobago Gazette. And then we need our Minister of Trade and Industry to confer the compulsory status via a compulsory standards order. When that process is completed, then there is a meeting to roll out the standard, and that is normally handled by our implementation division. and a moratorium will be given for the enforcement. So we are looking at most likely the next year for some level of enforcement. But the first step is to get the standard completed and have it declared and given that compulsory status. So I would say perhaps in the next financial year, but I cannot give a definitive time.
Thank you. No, that helps a lot. Thank you so much.
So there's some way to go before we are at the point where we're ready for enforcement.
Thank you, Nadita.
And Giselle, to answer your other questions, there are coated paper products that are certified for industrial compostability. Rather than having polyethylene coated paper cups for coffee or soup containers or so on, there are PLA coated ones or those coated with other industrially compostable resins. So there are alternatives that are available. And in fact, the ones that are PLA coated are actually microwavable. The ones that are polyethylene coated are not. So there's actually you gain actually a benefit in one, even though it costs more. So they are available. I think someone had asked about coated paper plates. That's a difficult one because there are no industrially compostable coatings for paper plates at this time. Unless you do something like put a PLA coating on it, but then why not just have a PLA plate? So that is one thing. Acrylic coated plates are not accepted in the US. They are accepted in Europe. So it depends on, and this goes to your last question about which certifications do you accept. You can go with the tightest certification requirements, which are ASTM D6868. And BPI used to only require to that. They've changed it somewhat. CMA, Compost Manufacturing Alliance, only requires that. So if you want to go with one agency, you can go with the toughest agency. But the question is whether you're going to be recognized around the world. And the answer to that is no. Europe only recognizes European standards, certifications. North America will accept European standards if it also meets US standards. But if you go to California, California is very, very specific as to what you can and cannot say and cannot have. So understand the issue about certifications. My recommendation is test to the toughest standards and then go to agencies that will accept you to do that. And when you do that, then you'll be accepted everywhere. But yes, that is a problem. Every place is a little bit different. The differences seem minor, but they can add up because of the certification differences. And it should be noted, certification agencies do not have to follow standards. They can use them as guidances. They can add or subtract requirements from standards when they do the certification. And all the certification agencies do that.
So, Dr. Okamoto, so if I understand correctly, PLA coded products are okay then?
Generally, yes. Some of them are not, but most of them are.
In Trinidad, for this standard, they are.
Yes, they should be.
Okay, thank you so much.
Thank you, Gisela. So I will just go through some of the questions very quickly before I go to Tessa. So there's a comment from Wayne Billins. Has a study been done to understand the effect that the standard might have on consumer prices? So Dr. Okamoto, based on your experience, could you give us some insight into what is the economic impact of setting these type of standards?
This packaging definitely costs more than existing packaging. A pulp molded plate costs significantly more than getting a polystyrene or expanded polystyrene plate. However, typically you're talking, even in the worst case for pulp molded, 10 cents per item, 15 cents per item. Compared to the actual cost of the food itself, it's small. So yes, it's much higher on a packaging cost, but on a total product cost, especially when you're talking takeout, generally it's a smaller portion. You may want to raise your prices, but it's not going to be to the, if it's 10 times for, 10 cents for a pulp molded plate versus, a penny for a paper plate or a polystyrene plate, you're not going to raise your prices 10 times on the food because it's a 9-cent increase is the way to look at it. And that may be a small percentage of your total takeout product cost.
Thank you, Dr. Okamoto. So I'll just go to some of the other questions in the chat before I go to Tessa. Has any economic feasibility studies been done on industrial composting facilities in Trinidad and Tobago? This is a national level discussion, and TTBS is given the undertaking that we will liaise with relevant ministries and agencies to discuss that matter. And I'm going, can TTBS identify any government agencies or private companies currently planning to construct any industrial composting facilities? So similar to the question before, we give our undertaking to have that discussion with the relevant ministries and agencies. We already spoke about the ASTM, the 6954 standard, and that came from Mr. Billins. Just some comments from Gabriella. Gabriella, do you want to give your feedback or reflection from the circular economy perspective? Okay, so I'll just read out her comments. She said, a reflection from circular and systemic vision, biodegradability can potentially be the loss of value of the resource beyond the nutrient for ecosystems. Policy should define where a biodegradable product is needed and promote reuse and rejection to enhance the flow of resources. And I think that comment is well noted. There's a question from Mr. Harris. I think he wants absolute clarity. Would it be correct to state that the landfill biodegradable items fall outside the scope of the proposed standard?
I say yes. Nadita, I don't know what you think.
Yeah, I think as we have to look at all the comments that we're receiving. There is a clear need to have a discussion with some of the state entities to determine how we can move forward in the medium to long term. This particular standard is only one step in a potential holistic solution. And one of the issues that we also need to look at is what is the title and redefine or relook and revisit the scope of the proposed standards with the possibility of addressing the other aspects at a later point. So there was a comment from Mr. Thackeray. So he spoke about the PFAS chemicals, and his comments is well noted as well. And I guess he's asking for some more information about the PFAS chemicals and the impact they have on human health, the environment, and compost we may use to produce food items. So Dr. Okamoto, did you want to comment on that?
Yes, there are a number of products that are now PFAS free that are pulp molded, and they have different solutions for how to do it. In one case, you add a PLA coating over top. And actually, there's some distributors that actually sell all of these solutions. You put a PLA coating over top of the pulp molded product or some other biodegradable coating, probably the most expensive of all those solutions. There's some products where they just remove the PFAS. And honestly, I've tested a number of them and they're horrible. The soil, the water and grease goes right through them. There's 4 solutions. There's another one where they're pushing the use of a chemical that is most pulp molded and paper products called AKD, where they're using a very high content of that. I am not certain anybody's actually done any studies as to the effect on health and the environment of that high use of AKD. And don't ask me what an AKD stands for. It's a chemical name and I don't always remember it correctly. And then the last is there's actually a way to do it by doing some by doing high pressure molding so that you actually make the surface impenetrable just because it's so tightly packed. So there are different ways of doing it. And I'd say the last one I have found to be the most effective, both from a cost and ability to hold out moisture and grease. Though, you know, taking out the PFAS alone without doing this other step is definitely the least expensive, but it's also not functional.
Thank you, Dr. Okamoto. Just a technical question now. Our landfill is compacted by heavy equipment moving on top of it. What is the minimum depth in a landfill for anaerobic biodegradation?
Anaerobic biodegradation does not have a specification standard by anybody at this time. However, I would suggest that you're going to use the same standards for heavy metal content in sludge that is used for industrial compostable products, because it's similar to sludge in the type of process you're going to be using. So 50% of a sludge requirement, or what would be the requirement for compost, since the digestate generally eventually becomes compost also.
Okay. So there's some other comments in the chat. You know, the comment from Mr. Harris is well noted. So he indicated corn is used to make many compostable products. Corn is food for humans, chicken, pigs, cattle, etc. Cattle is a source for beef and dairy products. Using corn to make tableware is a multi-nation solution to problems that will cause food prices to rise. What is the poor to eat? I think that comment is well noted. We don't have an immediate response to that. We're dealing with the technical requirements for a particular standard and the appropriateness of the limits and the testing requirements. That is a wider societal issue.
It is a societal issue, but it's actually been studied quite heavily. Plastics packaging, it is best not to use food source feedstocks. However, the amount that is used for, even if you took all the plastics in the world and converted it to being made from corn or sugarcane or other things like that, you would use 10% of the total food production worldwide. And that's to produce all plastics, polyethylene, polypropylene, and so on. Right now, the total amount of for PLA and so on it's minimal. If you consider that in the US, we fallow 10% annually the amount of land for growing food crops. So right now, it's not really an issue at the volumes that it is, and it is not anticipated to be an issue down the road. Where it is a major issue is where, like in the US, we have a requirement for ethanol-based alcohol to go into gasoline at 10%. That actually has doubled the amount of corn that has had to be grown to meet that requirement. So the requirements for that are much worse than for anything in the packaging industry right now.
Okay, thank you, Dr. Okamoto. Again, there's another comment from Florian Mitchell, and looking at the cost implications and the application of the industrial composting facility to Trinidad and Tobago, and I would have highlighted that we need to have the wider level discussion with the key ministries and agencies. So we would have spoken about the cost implications, the environmental implications of the industrial composting facility. Based on a comment from Mr. DeLeon, we had addressed that before. And we would have addressed the issue of the backyard composting. So we would have done that previously. We had another comment from Vandana about PLA, so that is well noted as well. And I would now go to Ms. Tessa Charles. I apologize for the delay, but you can unmute.
Hi, good morning, everybody. I may have missed some things, or maybe misunderstanding. I am an importer and I'm having some issues over in my country, Grenada, as it relates to PLA line products and the ASD 5511 tests, since we're using the landfill system. And there are a number of different explanations for the ASD 5511. Can you tell me a little bit more on the ASD 5511 test and the landfill and the implications with PLAs? Let's say, for example, our food boxes that have a PLA lined, which is 6400 approved and 6800 approved, but they seem to not to want to accept that because it's PLA lined. Can you give me a little insight on that?
Don't know all the backgrounds, sorry, Tessa, but D5511 is for anaerobic digestion. It's not a test for landfill. 5526 is, and a lot of companies use 5511, but it's not the appropriate test. The other thing to note, PLA does not biodegrade in anaerobic digestion or in an anaerobic environment. PLA only biodegrades in industrial composting and to some extent home composting. It is one of the materials that is only compostable. It is not soil, it is not water biodegradable, it is not anaerobically digestible. So for, like, if they require landfill biodegradability, they shouldn't accept it. So 6400, 6868 are specifications that tell you what the requirements are for industrial composting, and it would meet it most likely unless they crystallize the layer, and this is getting technical, of the coating of the cup. But it would not pass 50. It would not have a high level of biodegradation by 5511, but 5511 is not the right test for landfill biodegradation. And it should be noted, as I stated before, all the landfill biodegradability test methods are accelerated. We do not know the correlation between the accelerated test methods and the actual in the landfill. And all studies have shown that a well-maintained landfill goes dead in 10 years. Therefore, if the landfill biodegradation takes longer than 10 years, that's non-information, because you can't get to that length of time.
So, Dr. Okamoto, I'm looking at the time, and I just want to address the last remaining questions in the chat, and then we can move to close. So a comment from Mr. Harris: there are many types of anaerobic biodigesters, which I guess he's saying the costs are comparable to the industrial composting process. If you could comment on that.
They're not comparable because they're anaerobic versus aerobic for composting. Anaerobic digestion is a great way to especially take care of waste or anaerobically digestible waste, especially in urban environments where you don't have a lot of space, because they occur in vessels. In many places, they're also associated with your solid waste or wastewater treatment facilities for treating solid waste, and so on. Yes, there are lots of different ways to run it. You can run it what they call dry, which is 10 to 20 to 25% liquid, or you can run it wet, where it's 60, 70, 75% liquid. So depending on how you run it, your conditions do change, and how you do your testing will have to change too.
Okay, so I think this will be the last question that we'll raise. And it came from Merlene Samlal saying, what about the styrofoam containers currently on the market, which are being stamped biodegradable? How is this being allowed? So I think this is clearly what the standard is trying to address.
Yes, we have those in the US too, even though it's illegal in the US.
And I would say that is the purpose of certain compulsory standards, regulation, legislation, to ensure that that level of misleading information is not provided to the consumer and then end up for sale in the local market. So I would just like to invite Gabriella to give her closing remarks, and then Dr. Okamoto, I will move to you. So Gabriella, if you're available.
Yes, Nadita.
Okay, thank you.
Thank you. Thank you. Sorry?
We just wanted to invite you to give your closing remarks. We would have noted your comment in the chat, the linkage with regard to biodegradability and the circular economy and how important it is to have the proper policies being set at the national level.
Okay. Sorry, my English is a little poor for this situation, but we see that we have do a very deep discussion about biodegradability and compostability. Our congratulations, because you are very advanced to the subject, and a lot of things to construction about this situation. Sorry, Mada is my colleague y tuvo que partir. Sorry, my English is not too good, but thank you for the invitation.
Thank you, Gabriella. We appreciate the contributions from both you and Madhan. We look forward to working on the Kabarek project. Dr. Okamoto, I wanted to turn it over to you to give your closing statements, and then I will go to Mr. Rodney Ramnath, our Acting Executive Director.
Thank you, everyone, for being here and for listening in, and once again for TTBS and you all to invite me to talk on this important subject. Along with Gabriella and Madda, this is very important as part of a circular economy, a global warming, a carbon's life cycle perspective, and we need to keep that all from a holistic standpoint. This is only the beginning. There's a lot of steps to go. But the idea is let's set, with TTPS and everyone else, let's set where we want to go to and figure out how we need to get there. It may not happen in the next 2 months. Maybe it takes a year, maybe it takes 2 years, but you know, having some sort of a timeline and plan for getting there is great. And every step we take will be an improvement on what we all do around the world for, you know, helping the environment. And, you know, like I said, this is a first standard. There will be follow-up standards most likely coming down the road. It's very difficult to chunk off everything in one bite. We all eat things one bite at a time, and that's really what we're working on here. Thank you.
Thank you, Dr. Okamoto. I turn it over to Mr. Rodney Ramnath, our Acting Executive Director, to give his closing.
Hi, good afternoon, everyone. So it certainly was a very informative session today. I'd just like to thank all of our participants for coming, manufacturers, importers, distributors, etc. I know that this is a very important issue and also one that has the potential to impact the industry. So we are very grateful that you are able to make the time to be here today and to provide your comments on the draft national compulsory standard. I'd also like to thank our presenters, Ms. Campos, Ms. Soler, and especially Dr. Okamoto for facilitating the session today. So with that, I'll hand you back over to Nadita to close.
Thank you, Rodney. I would also like to thank all the participants and presenters for today's session. All the comments are well noted. The discussions regarding landfill biodegradation and industrial composting facility is one that we've been looking at very actively. And as TTBS, we give our undertaking to liaise with the relevant ministries. And as Dr. Komoto indicated, we need to have a start. So this is one of the key projects that we're supporting the Ministry of Planning and Development on regarding the ban of the expanded polystyrene products. And the standards, I would like to say, provide one aspect of a technical solution, but there are many different components. As we would have seen today, there's a need for training, awareness, and it is our hope that as TTBS and through the support of both PTB, the Kabarek project, and Dr. Okamoto, we were able to bring some insights into some of the technical requirements. There are some things that TTBS will not be able to address on its own, so it requires national level dialogue. And I think Shan would have mentioned, public-private sector partnerships as well. And all of those things form part of a holistic solution. So all the comments are well noted. We are given a 2-week extension for any further written comments. The deadline for any comments will be the 18th of March. I have provided the email addresses for myself and Adrian in the chat. So please feel free to reach out to us if there are any additional issues. So once again, thank you to all the participants or the members of our National Merit Committee, chaired by Dr. Beckles, our Internal Advisory Committee, chaired by Ms. Nadia Prasad, the members of our Conformity Assessment Divisions, and Gabriella and Madhav. We appreciate your support, especially at the short notice, and a special thanks to Dr. Okamoto, who has been on this journey with us since 2019 as well. So thank you, everyone. I appreciate you all staying an additional 40 or so minutes, and we will be in contact regarding the next steps. And take care and be safe. Thank you, everyone. And we will seek to close the session shortly.
Thank you, everyone.
Okay, thank you, everyone.
Thank you,
thanks,
everyone.
Thanks to the TTBS standardization team, Adrian, Kenley, Andy as well for providing the technical support for today's session. So goodbye, everyone. Take care.